Composition function. Okay, so defined as a function whose values are found from two given functions by applying one function to an independent variable and then applying the second function to the result. Function that depends on another function. It's created when one function is substituted into another function, taking out the output of the first function and using it as the input in the second function. The domain consists of the values from the independent variable, and if given a letter of another letter, f of g, with an open circle, plug the second letter's function into every x presented in the first function and then solve.
So this is a general example. If you have f of g, you're gonna plug in f first, and then for every x that you see, you're gonna plug in the g function, and then you're just gonna solve it and distribute, and then just do it as a normal function. So this is g of f, which is the other way around. So now you're gonna have g, and then for every x on the function of g, you're gonna plug f into that, and then you're just gonna solve it again, just like we did for f of g.
The concept of functions was developed in the 17th century. It's defined as an expression that describes a relationship between two variables, a dependent and an independent. Rene Descartes wrote a book, Geometry, and in it used a concept to describe the relationships it had mathematically. It wasn't until about 50 years later when the publication of the book that was term of function was introduced. It was introduced by Gottfried Wilhelm Leibniz. The notation for a function, y equals f of x, was later introduced by Leonhard Euler. There were different kinds of functions since the development of the term linear, polynomial, exponential.
So this is what we were given in the assignment, and then there's just like a hint to make sure you find a common denominator when needed. So this was our findings for up there. It shows the composite, and then you're just doing f of f, or like if you have h of g, then that's where it lands. And then we have some general examples here. For f of h, this is how we figured it out. So you have f, you have h, and then for every x, you're plugging in this h, so then all you're left with is 1 minus x. And then for j of g, you're given j and then g, and then so you're writing for every x and j, you're plugging in g. So then you have to get a common denominator, and that's what you end up getting.
So findings is like surprisingly enough, a lot of results were similar to other solutions. Some solutions were actually the same within the same row, which is interesting to see, since they are different functions. And just like the definition stated, we were able to see how the functions were broken down into simpler functions.
And there are our sources.
Thank you.